acid chlorides can be used to synthesize amides. There are 3 examples here. In the first example, we're treating an acid chloride with ammonia, and that produces a primary amide. In the second example, we're using a primary amine that will produce a secondary amide. And in the third example, we're using a secondary amine and it produces a tertiary amide. If you treated an acid chloride with a tertiary amine, you would get no reaction. In each case, it does mention 2 equivalents of the amine. We use 2 equivalents of amine instead of using an equivalent of pyridine. So the amine acts as a base instead of pyridine to prevent the formation of HCl. Let's look at the mechanism. We have an acid chloride. The carbonyl carbon is very electrophilic and will react with amines directly. In our example, we'll use a secondary amine, but the reaction of ammonia or a primary amine would be analogous. The first step is a nucleophilic attack of the nitrogen on the electrophilic carbonyl carbon, and a resonance arrow to move electrons up to the oxygen. That forms a tetrahedral intermediate. And since chloride's a very good leaving group, we can have loss of chloride in the second step. That regenerates the carbonyl, and we'll show 1 chloride being formed. Because we have a second equivalent of amine, that's the best base in solution, and that will do the proton transfer. Which generates the product amide. The byproducts are the ammonium chloride that's formed from the proton transfer. So overall, notice that we used an acid chloride with a secondary amine, and we formed a tertiary amide